Hi everybody, and welcome to another video of the Bravo project. Today we'll be talking a little bit about some tips and tricks in regarding to soldering the project. Now that the kit for the project is available, I thought it will be useful to actually go through some of my experiences with soldering this project and share it with others so that they have a smoother process of building this project. Now, obviously, the end result is here. As you can see, we will be soldering 7 different PCBs. 2 of those are like add-on PCBs to the project, and then there's 5 main PCBs in the middle. So for each PCB, there are like little tips that I'm gonna give it to you in this video. And I would highly recommend that you actually watch each video for that section before soldering it. It's going to help you in doing the right direction, let's say, for a part, or having enough space for, let's say, a component there. Now, before we start looking at each specific module, there are 2 points that I have to mention here. One is if you are brand new to soldering, then I would highly recommend that you do some practice, soldering practice, before actually doing the soldering on this project. And the reason being is that some of these parts, including these, header female connectors, the pins are very close to each other, and you're going to be working in a very tight space. So it's better to actually do some practice. And if you have never done soldering, it's just get one of these PCBs, or what they call it, the perf boards, and do some practice, soldering parts, and make sure that you are comfortable with soldering. So another point is, if you remember in the previous video about the kit, I actually talked about the fact that all the PCBs for this project are lead-free. And that means basically that you need a slightly higher temperature when soldering on lead-free PCBs. Again, normally if you're doing soldering, let's say at between 350 and 400 degrees C, you normally will be like 10 or 20 degrees higher when you're working with lead-free PCB. So consider that. And with that, let's just get started with each module. And I'm gonna basically divide the video into multiple sections, and we're gonna go through each module individually. That would, I guess, make it easier for you to switch back and forth between different sections of the video if needed. All right, so let's get started with module number 1. Our first module, as you can see, module number 1 is our program counter and clock on the same PCB. There are some rules that applies to all the PCBs. So let's first talk about those actually. So if you're in general new to soldering, especially the IC sockets for this type of projects, first of all, you get IC socket for every IC in this project. So you will not be soldering the ICs directly on the PCBs. And the reason for that is you're not basically giving the ICs let's say a temperature shock, or also it will be easier if something is wrong with the chip. It will be easier to switch. And also you could probably use that IC later. You just take it out and use it. But if you solder it to the PCB, it will be very difficult to desolder it. So we'll be using these IC socket, different size. There are actually dip 14, dip 16, and dip 20. Means this is a number of pins. And you basically just put them right in there, and it's gonna fit in right in its place. Now what I normally use to solder these parts is that I'm gonna use one of my hands, or one finger here, to hold the socket in place, and I'm gonna flip the board, and basically I'm gonna hopefully you can see it in the videos. These are the pins at the back of the board, and I'm gonna normally bend one pin at each side on the opposite sides using a tweezer or something, as you may have seen in the videos. This way, this basically holds the part in place if I flip it back, and start soldering. So this is obviously requires a little bit experience with it, but I guess that's a good way of holding these parts. And normally with any type of PCB soldering, you normally start with the smaller parts. First solder smaller parts or low profile parts into PCB, and then continue with the bigger parts. Now in regard to this specific module, you're gonna have obviously the bus pins and or bus sockets here, and this is important because as I mentioned, these modules will be stacked on top of each other. So what you want to do is that you want to have enough space in between each module so that they don't basically touch each other and make a short. So in order to do that, I included these stackable header females or female sockets. However, if you look at it carefully, on the pin side, you see that we have some plastic spacers, and these are important. These are kind of standard, I guess, in the size. Each of those plastic spacers are like 2.5 millimeters. Two of those will be 5 millimeter spacing in between the socket and where the pin actually starts. So this is important because this 5 millimeter actually provides us enough space so that we could stack those modules on top of each other. So let me insert that into the board, and you're gonna see what I'm talking about. So if I can insert that into the board, now you see that the female socket is actually standing a little bit higher, right? And that provides, when you stack the next module on top of it, it provides enough space here and enough clearance so that all the parts are actually on the board, are not touching the board above it. Now that's important, and for some of the modules, because all the parts are like low profile, you're probably gonna get away with one spacing. But I guess these plastic spacings are not easy to remove and insert. So I guess as a standard, you could just leave it as two spacing for. Oh, excuse me. You could leave it at two spacing for all the modules, and just it becomes a standard. So you get 12 of these in the kit, and each board is gonna need 2 of those. However, one of the boards, which is our Arduino Mega Shield board, that one uses non-stackable, and then we're gonna talk about that once we are there. So with these long P's, you're gonna get 12, and 6 of the boards you're gonna use these female sockets with the spacing. Now, other than that, here the only other thing that I think I have to mention is in regard to the resistor array. So you're gonna get a bunch of those resistor arrays. One is on this module, and there's another, I guess seven of those are on the LED board. So those LED arrays, as I probably described them in a different video, they have 8 pins, or excuse me, 9 pins. 8 of those are actually one side of a resistor, and then there is one common pin. So if I hold the resistor array like this, the pin on the left hand side, the first pin on the left hand side, which is this pin here, is basically the common pin. And if you look at the boards on the PCB, you see that one of the pins are actually a square shape. Hopefully you can see it in the video. So the one which is actually a square shape is for the common pin. So essentially it's quite simple. The resistor array just sits like this on the board, and this is pretty much the standard across all the project. Now other than that, another thing that I would like to mention here is the socket for the crystal oscillator. Just like any other chips on the PCBs, for crystal oscillator we will be using a socket. However, you could get the sockets that are specifically designed for crystal oscillators. I actually used those in the past, and they are not very reliable. I mean, they get loose easily, and then your crystal oscillator essentially will be moving around. So I decided to actually use these the same DIP14 IC sockets for the crystal oscillator. However, the point is that for the crystal oscillator you only have 4 pins. However, you have here 14 pins. So what I've done is actually I am taking out all the pins in the middle and just leave the 4 pins on the corners. The end result is that you're making a socket for your crystal oscillator, and at the same time this socket is actually more reliable, and the oscillator sits really nice on it. It's tight, it's not moving, and so on. So how you do it, essentially you need a plier, and you basically hold, hopefully you guys can see it, you hold the pin and push it out. So from this side, if I hold the pin and push it out, and then I could grab the pin from this side and take it out. So this way, if I continue this process for all the pins in the middle, I could basically take out all the pins and just leave the 4 on the corners. So the end results will be like the board that I built. So let me show it to you what will be the end results. So that's the end result. This is our oscillator, which sits really tight and nice. But if you look at the socket, it's just a normal DIP14 IC socket that all the pins are in the middle are taken out, and we only left the corners. And as you can see, the oscillator sits very tight and nice on this board. All right, so other than that, the only thing that remains on this board is actually these clock rate selector pins, and those needs to be male header pins. So I'm providing a bunch of those header pins, which comes in a row of 40 of them. The only thing that you need is to cut them to the size that you need. For example, in this module, we need 2 of those, and each of those have like 5 pins. So you're basically gonna cut 2 sections here with 5 pin each, and then solder them on the front of the board, and that's gonna be basically the end results for that. All right, so I guess that's really all about the clock and program counter module, or module 1. So let's move on to the next module, and that's going to be module number 2. Module number 2, I guess there's nothing special about it. I guess we, with the information that I provided in the first module, should be able to solder everything here. You're just gonna need to solder a lot of ceramic capacitors in this project, and those that are actually sit in front of the chips are the 100 nanofarad ones, and those are basically the brown ones that you get in the kit. And I guess that's about it. So the end results for this module is here. So it's gonna be probably quite easy. So that was an easy module. Let's move on to the memory now. So this is the next module, memory module. It should be quite straightforward, and there's not too much of a difference in regard to the soldering. Other than that, you see that we have a bigger chips here. One of them is the RAM, and the other one is our flash memory. Now you're gonna get these IC sockets for both RAM and the flash memory. However, if you look at the space around this, I intentionally left a lot of space around this flash memory, and the reason for that is I thought maybe someone wants to actually have a ZIF socket here. So you know, this is a ZIF socket that probably you could solder directly. It is not required actually, but this chip here is one of the chips that we will be probably programming through our flash programmer. Now, if you want to do a lot of programming on this chip later on, and let's say you want to develop a new operating system for the computer, then probably you're going to take out and put that chip back in there many times. And that's why maybe it makes sense for some people to have a zip socket, and that's why there's enough spacing here to actually, for those of you who need to do that, have a zip socket installed rather than just a regular IC socket. Again, if I can insert that here, that's going to be like this. And you see that there's enough spacing so that you have a zip socket. But another trick is that you could actually just write like a normal way in solder one of these IC socket here, and then mount the zip socket on top of it. I mean, this way you would be able to have the chip inserted just as you normally do, but you also have the option to actually mount a zip socket. However, I do not recommend to mounting the zip socket directly on this sockets, because what will happen is that this zip socket's pins are a little bit thicker, I would say, and when you insert them into these IC sockets, it's actually loosen them up. So what I normally do, I do a trick, and I actually use another one of these IC sockets on the zip socket. So this way, it's a little bit tight. You have to use a little bit pressure here to mount it. But I guess once you did that, then you could mount that on top of the other IC socket. This way, you actually will not be loosening this pins. Now I bent some of these pins. That's why I'm not trying to insert it. But again, that's a way of doing it. And other than that, everything else is quite normal here, other than you get one extra capacitor here, which is a ceramic capacitor. It's a different value here. Just make sure that you pay attention to the value of the capacitor. As I said, most of the ceramic capacitors are 100 nanofarad, and they should be quite clear on the board. And also, if you look at the capacitor itself with a magnifier or something, you can read 104 on them. However, there are two other ceramic capacitor that has a different value in the project, and one of them is here. This is a 470 picofarad capacitor, and that has actually a different color in the kit. It's shown with a blue color, and I guess that's it. That's really all about the memory. Now the end results of the memory is here. So this is the memory module after you build it, everything. So the next module is our UART module, and this is basically the PCB for that module. Has TX and RX. Again, nothing different here, other than we have a actually capacitor here. That's an electrolyte capacitor that you install here, and basically it's a voltage regulator, I guess. And then you have the USB to TTL module here, which will be sitting right here. So again, I will be providing one of those in the kit, but as you can see, it has not been soldered to any header pins. So again, you'll be using a couple of these header pins that are provided in the kit. You'll be cutting them to the right size for here, which is I guess 9 pin, 2 of them, and then we're gonna solder that using those header pins onto the board. Now, if you look at it, there is a little bit spacing issue here that actually I noticed even after revision 1.1 of this board, that when you solder this part here, this pins that we are not actually using will be basically blocking our capacitor, or the other way, the capacitor is actually blocking these pins. So what you could do is you can shorten these pins, or like bend them in a way so that you could solder the capacitor, and also you could solder this part. I'm actually going to take care of this issue in the next revision of the PCBs. So just in case you receive one of these PCBs that actually have this capacitor in the way of this module, then again, as I said, what I have used for myself is that I just cut these pins shorter I guess if you cut them by 2-3 millimeters, they will fit perfectly. Okay, so other than that, again, let's move on to the next module. Well, before we move on, we have another different ceramic capacitor here. As you can see, that's a 100 picofarad capacitor, and this is the other ceramic capacitor that actually has a different value. But as you can see, it's a single capacitor on this side, so it's clear that this is different. And also, this one has a blue color in the kit if you're getting the kit. Or maybe the color changes in the future, so I will not guarantee that always going to be blue, but read the value of the capacitors before soldering them to the boards. Now let's move on to the next module. So our next module, which is module number 5, is actually our control logic module. Now in the control logic, you're gonna get 2 flash memories, and again, just like the memory module that we talked about, you could use just the provided IC sockets. These are 32-pin IC sockets. You get 2 of those, and you could basically solder those, or as I mentioned, you could use actually ZIF sockets in those. Again, these are the 2 flash that we actually will be programming later using our flash programmer. And again, this is one of those areas that maybe you could be creative later, and let's say write a different opcode for your computer, and then therefore you probably would need to program these flash memories many times. So that's something that you could do it. We have actually another capacitor, ceramic capacitor, 470 picofarad, which is different than the others here. I forgot about this one, so this one is also different. Now I guess that's about it about control logic. So let's have a look at the next module, which is our LED module. Now the LED module is quite simple. You just basically be soldering a bunch of LEDs, and you also have 2 chips here, quite simple, but you get a bunch of those resistor arrays that we talked about it a couple of minutes ago. So those are simple. Again, on the footprint you see that one of the pins actually have a square shape. This is the common pin. One more thing before I forget is actually the directions of the LEDs on the board. So you know that LEDs have 2 pins. One is the anode and the other one is a cathode. So you want to make sure that you solder the LEDs correctly, and how you do it is that if you look at the printing on the board, you see that one side actually a flat side for the LEDs, and that's basically should match the flat side of LEDs. Now it is difficult probably here to see that actually all LEDs have like one flat side and the other side is completely round, but again, if it is difficult to see, what you could do is that just use the length of the pins. As you can see on this LED here, if my camera focuses, so you see that one of the pins are actually longer than the other one, and that longer pin is our anode pin, or our positive pin. So when you actually inserting those LEDs into the board, remember that the positive pin or the anode pin basically goes to the lower hole here. So you see that we have 2 holes, so the longer pin goes to the lower hole and the shorter pin goes to the higher hole. So, and that's pretty much the same for all LEDs on this board. So that's something that you want to make sure they do it right, because if you actually solder the LEDs the other way, obviously it's not going to work. Again, that's about the LED. And finally, let's have a look at the Arduino Shield module. So the Arduino Shield, again, I guess that's the easier one to build. There is not too much other than a bunch of headers and sockets. Now for Arduino Shield, one important thing is that as I said, you get a bunch of these header pins, But you want to make sure that for the Arduino section inside, not the female header pins, female header pins just will be soldered normally. The only difference is that we actually will be using a shorter pins here. This is the only module that does not have a stackable female header pins. And the reason being is that this is going to be normally sitting at the bottom of the build, and also we will be mounting the Arduino Mega at the back. So as I said, we needed some clearance here to actually be able to mount the Arduino Mega itself. That's why this module comes with a shorter female basically sockets. These are not stackable, so they just sit here this way, as you can see, and you don't need clearance here because there's nothing on this board. This is the module that actually comes with the shorter header pins. The rest of the modules use the same longer stackable female headers. Now, for this module, as I mentioned, one thing that you want to make sure you do it right is that you will be cutting these header or the male header pins to the size. For example, this is a 8-pin section, another 8-pin section, another 8-pin section, and so on. And then you will be soldering them from the back side. So meaning that the final result, actually, if I want to show it to you here, is that, as you can see, the female sockets are in the front. However, the male header pins are soldered at the back. And the reason being is that obviously you want to mount your Mega from the back side of the board, right? So that's how it works. I just wanted to make sure that you do it right, because that's how it works. So that's how it mounts. So make sure that these pins are all soldered to a header female pin at the back of the PCB. And then I also provide you with this spacers, risers. They are included, 4 of them in the kit, so you could basically build it the same way that I build it here. Other than that, I guess that's really all about it. I also mentioned previously in one of the videos that I'm actually using a little bit of a sticky tape here, because when you're mounting this Arduino Mega to the board, you see that this USB port is actually touching part of the board here, and that may cause a short. So somehow you need to cover that USB port. Again, as I said, I'm using a little piece of a foam here for isolation. You could probably use anything to isolate those. Now, I guess that was all the points and tips about soldering the project. Again, it's not that complicated, but I thought maybe some tips and tricks help you to have a smoother process in building the project. If you have any comments or questions, you can post it here on YouTube, or also you get support from the 8bitkits.com website. If you source the kit from there, feel free to post a question. I'll be more than happy to answer the questions either here or there. All right, so with that, I hope that you guys enjoy building this project if you happen to get the project, and I'll catch up with you later.